My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 602. In this lecture, I will continue my discussion on padding and strides. I already discussed about padding in my previous lecture, that is in lecture number 601. Let me explain what is stride does is. Suppose I have 6 by 6 matrix here and let's assume I have 3 by 3 kernel. Let me see what I can do here. Just observe what is my n value here. N value is 6 and k value is 3. Why? Because k cross k kernel, n cross n input image. When we took this kernel, we first place this kernel. Just see what will you do. Just we are placing this kernel here. Again you are shifting by 1 unit, again you are shifting by 1 unit, again you are shifting by 1 unit, isn't it? So that which values are getting, you will get first value, second value, third value, fourth value. You will get all these values, isn't it? You will get all these values. Again you can shift, again you can shift by not only horizontal, like this also. First shift, you are shifting by 1 unit, just see here. So that you will get these values. Which values you will get here? Anyway, this procedure I already discussed. I need not repeat it again. It's simply repetition, I can say, isn't it? So shifting by 1 is called stride of 1, isn't it? Because you are striding or shifting, isn't it? You are striding or shifting by 1. That's the I can say shift by 1 means stride of 1, but you can also have shift by 2, isn't it? Shift by 2 is called, it is stride of 2, isn't it? What is the meaning? Shift by 2 is called, it is a stride length of 2. So when I have stride length of 2, what happens? Instead of shifting by 1, let me draw this here. Suppose I have 6 by 6 matrix. Let me assume like this. What is the meaning? Let me draw this 6 by 6. Suppose if I have 6 by 6 matrix like this, this is my, what is this? 3 by 3 matrix. If I am shifting by 2, shifting by 2 means what? This is basically stride of 2, because this is my, what is my first value? This is yes, what is my first value? This one is first value, isn't it? This one is first value, and again I must shift it by 2 units. That's why I just say here you are shifting this one by 2 units. Just see you are shifting by 2 units. That's why it is, this is basically a stride of 2. This window you are shifting by 2 units. Just observe this particular 3 by 3 kernel, how we are moving. We are moving by 2 units, isn't it? I shift to 2 cells, isn't it? If I speak strictly, what's happening? I can keep the as we are saying, because of this one, I will get first value. Because of this one, I will get second value. Isn't it? I shifted by 2 cells. I can say what we are doing, you are shifting by 2 cells horizontally. When I say my stride equal to 2, I can say, let me say my stride equal to 2, s equal to, not just horizontal stride. Instead of shifting 1 here, again we shift 2 here. This is my shift by 2. Here this is how many units we are going to shift. You are going to shift by 2 units. So whenever I say my stride equal to 2, that is s equal to, what it means is you are shifting both horizontally, isn't it? Just see, you are shifting. Now you shifted vertically. This is known as vertical shift, isn't it? Again, shifting both horizontally and vertically by 2 pixels. Stride s equal to 2 means what? Shifting both horizontally and vertically by 2 pixels. Stride is a very interesting concept. Just see, this is known as vertical shift by 2 pixels. Again you can shift it, just see, what is this? This is known as horizontal shift by 2 pixels. my stride s equal to 2 means you can shift horizontally 2 pixel, vertically also 2 pixel. Just try to understand. It is very simple concept, isn't it? Stride is a very interesting concept. Strides helps you to reduce the size of the matrix. Let me show an example. So if I have an n cross n matrix, let's say I have n cross n matrix. Let's say my stride equal to s, my stride is s, and my kernel is k, isn't it? That's k cross kernel, k cross k kernel, n cross n image, s is stride size, k is kernel size, k cross k. Yes. Now what's happening? The result that I will get here is, this is floor of n minus k by s plus 1 into floor of n minus k by s plus 1. Here you are performing the division operation, isn't it? You are dividing by s. Look at this. You have 6 cells. If you observe how many cells you have 6 cells here. 1, 2, 3, 4. There are 6 cells. Let me assume, what is this? Yes. 1, 2, 3, 4, 5. I assume this is one more cell. I forgotten to draw this one more column here. Assume there are 6 cells. How many 3 by 3 kernels can be slide on 6 by 6 matrix, isn't it? Now just see, I corrected it. Just see how many, 1, 2, 3, 4, 5, 6 cells, isn't it? It is a 6 by 6 matrix. Question is, how many 3 by 3 kernels can slide, because you are shifting every time by 2. Because you are shifting by 2, you have to divide by 2. That's why n minus k by s, isn't it? So this is very simple operation. If you have simple stride, the n by n matrix becomes smaller. Let's assume you have 6 by 6 matrix and stride length equal to 2. Just let me assume my stride length is equal to 2. If it is stride length equal to 2, what's happening? And the kernel is 3. What do we get here? What is my n? N value is 3. Just I am simplifying these things. My n is 3. My n is 6. That's why I am substituting n equals 6. What is my k? K cross k kernel. K cross k kernel means k equal to 3. My stride size s equal to 2. S equal to, is it 6 minus 3 by 2? 6 minus 3 by 2. 3 by 2 means 1.5. It is a floor. It is floor means what? This 1.5 can be treated as 1. Therefore, you will get what is the output matrix size? 1 plus 1 cross 1 plus 1. From the input matrix of size 6 by 6, just observe, from the input matrix of size 6 by 6, you will get an output matrix of size 2 by 2. There are some places where you want the input image and the output image are of different size and significantly smaller. Remember, if I just had 6 by 6, okay, with just k equal 3, if s was equal to 1, let me assume my n by n is 6 by 6, n cross n is 6 by 6, my k cross k equal 3, s equal to 1. What happens? You will get your input size is 6 by 6, your output size is 4 by 4 for s equal to 1. But what I want actually, I want much smaller. I want much smaller matrix. Here you are getting 4 by 4 matrix, but I want much smaller matrix. We will see why strides are useful in convolutional neural network. When we build we will see why strides are useful in convolutional neural network when we build a full-fledged convolutional neural network. Isn't it? Strides and padding are simple concepts that we will leverage when we design the convolutional neural networks. There are 3 concepts that we learn. What are first one, which is nothing but convolution. It is nothing but we learn the concepts of convolution, which is nothing but an element wise multiplication and addition and we learned just for anyway for n equal 6, k equal 3, s equal to 1, you are getting 4 by 4 matrix, isn't it? That's what we were discussing. Yes, what is this? Padding is used to create what is the basic idea behind padding? Padding is used to create the same size output as input. And what is the use of strides? So what is the purpose of strides? And strides is used to reduce size of input dramatically more than what a kernel would reduce, isn't it? Suppose if I have n cross n matrix, let me assume I have n cross n matrix, and if I have k cross k kernel with the padding p as padding, what is my s? S is stride. S is nothing but, let me assume S is stride, isn't it? My final matrix will be, what is my final matrix? N minus k plus 2 by s, this floor of n minus k plus 2 by s plus 1 by floor of n minus k plus 2p by s plus 1. So your n, because of padding, has increased. What is your padding? Therefore your n is increased to 2p. Therefore your n becomes n plus 2p as the size is increased the size by 2p. Your n plus 2p, isn't it? Your n plus 2p. Why you are getting plus 1 here, Jesse? Why you are getting plus 1 is always there from starting. Minus k by s. What is this minus k by s? What you got here? Of course, the floor, of course, the floor, obviously, we know the floor, very simple, of course, the floor of this, obviously, you have to take floor of this, isn't it? That's what we discussed. Very simple concept. So, whenever you are using convolution, padding, or strides, you can use these three simple equations. Actually, you don't have to remember these equations. So padding and strides, padding, strides, and convolution are three of the most important operations that will be used to construct convolutional neural networks. I request all of you to go through these concepts so that we will try to understand in future classes how to construct a convolutional neural networks by using these three concepts: convolution, padding, and strides. Thank you very much.